I'm back again, and we are going to practice factoring. I did notice there is another problem in this section that actually deals with Unit 3, so I'm sorry, there's one question a little out of order, but that's okay. Okay, so factoring. First rule of factoring, we always look for a GCF first. Sometimes problems have them, sometimes problems don't. All right, so looking at the 8 and the 16, can you think of what the greatest number is that could divide into 8 and also divide into 16? 8 can. 8 can go into 8 one time, and 8 can go into 16 twice. So the greatest common factor between an 8 and a 16 is an 8. And then do they both have G's? Nope. Do they both have H's? Nope. Okay, so that's the only GCF I have. Every time there's a GCF, you build one set of parentheses behind it. So I know right now what the answer is, but I'm going to keep working this. So 8 times this has to be 8G. So that would be G. 8 times G is 8G. And then 8 times this has to be 16H. So it would have to be a positive 2. 8 times 2 makes 16, and then I need an H. So 8 times 2H makes 16H. And that is the answer choice A. But I knew it couldn't have been anything else. This one didn't have a GCF out. This one said the GCF was 2, and this one said the GCF was 8H. So none of those were right. All right, this one. I still look for a GCF first, but there's nothing that can divide into 1, 14, and 24 besides a 1, and they don't all have X's. Okay, so as soon as I spot that there's 3 terms, 1, 2, 3, I do this little A times C rooftop business. So A times C, 1 times 24 is 24. And I want the numbers to add to make 14. So I'm trying to think of 2 numbers that multiply to make 24 and add to make 14. So I'm going to show you a couple things you could do. So if you did it by hand, you'd want to think about all the things that multiply to make 24. So you start making a list, etc. 1 times what is 24? Well, 1 times 24 is 24. Then you ask yourself, well, do those 2 numbers add to make 14? No. Okay, 2 times what is 24? 2 times 12. Then you ask yourself, do those 2 numbers add to make 14? Bing, 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 bing. Yes, they do. So I know my numbers are 2 and 12. The other thing you could do is you could go to y equals on your calculator and then put 24 divided by x in your calculator because it's what they multiply to be divided by x. And then I want to go to the table. So to get to table, I have to go second graph. And then these are all the numbers that multiply to make a positive 24. If there were decimals, I would ignore them, but there's not. Then you ask yourself, okay, do these 2 add to make 14? Do these 2 add to make 14? Do these 2 add to make 14? Do these 2 add to make 14, etc. And bing, 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 it's those 2. Okay, as long as this is a 1 in front, it's the easy one. You just got to go straight to the answer. The letter you're working with is X, so X goes in the front, and then you just write the 2 numbers you found. That's a positive 2, and that's a positive 12. And that would be my answer. X plus 2, X plus 12. And D is the one that says it. It just says it in reverse. But it's fine. It means the same thing. Okay, number 15. So first I look for a GCF. If there's anything that can divide into 4, divide into 13, and also divide into 9. And there's nothing besides a 1 that can go into all those numbers. Okay, so now that I spot that there's 3 terms, 1, 2, 3, I'm going to do my A times C rooftop here. So A times C, 4 times 9 is 36. And I want the numbers to add to make negative 13. Okay, so I could do what I did earlier, and I could write down 36, and I could start making a list and try to figure out all the things that multiply to make 36 and see if they add to make negative 13. Or I could use my calculator. It's really up to you. So I'm going to go to my y equals this time I type 36 because that's what I want them to multiply to be, divided by x. And then I'm going to go to my table. So second graph. And remember, there's numbers in the negatives and numbers in the positive. Well, let's talk about positives. Will two positive numbers ever add to make a negative? No. So they have to be negatives. All right, did these two numbers add to make negative 13? No. Do these two numbers add to make negative 13? No. Do those two add to make negative 13? No. Do those two add to make negative 13? Yes. Winner, winner, chicken dinner. -4, -9. All right, so those are my winners. Okay, so when this is not a 1 in front, we have to do it the long way. So this is what I call Dr. D. Drop, replace, drop. So I drop the 4t squared. I replace the -13t with these guys. So -4, don't forget to give him the t. -9, don't forget to give him the t. And then drop the positive 9 in the back. So the two middles have to have the same letter as this guy because -4t minus 9t makes -13t. So just remember that whatever the middle letter is, your two middles have to have that same letter. Okay, from here, since there's 4 terms, 1, 2, 3, 4, we factor by grouping. So I group together my first 2 terms and I take their GCF out. So what's the greatest number that can divide into 4 and 4? It's a 4. They both have t's. What's the greatest amount of t's they both possess? They both have 1. Okay, build your parentheses and let's get both of these guys back. So 4t times what is 4t squared? T. 4t times what is -4t? 4t times -1 is -4t. Okay, now let's look in the back. So I know I get to cheat a little bit here. Whatever is in this set of parentheses will always be what's in this set. So I'm just going to go ahead and put it there. Now I'm going to backtrack. What's the greatest number that can go into 9 and 9? A 9. And whatever this sign is always goes right there. Now let's just make sure this distributes to give us this. So -9 times t is -9t, and -9 times -1 is +9. Okay, so since this distributes to give me this, I know I haven't screwed up anywhere. Okay, the last step is very simple. Whatever both of these say, since they're the same thing, we write it one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, we write it one more time. So 4t minus 9. And do you see that answer somewhere? It is C. So C has it written in reverse order from us, but that's fine. Okay. Number 16 is next. Okay, it says factor. If it can't be factored, write prime. All right, so remember your first rule of factoring is to look for a GCF. So first I'm looking at the 12 and 27. So is there a number that can divide into 12 and also divide into 27? And if so, who is it? And you want the biggest one. 3 can go into 12 and 3 can go into 27, and that is the biggest guy. Okay, now do they both have V's? Nope, it's just a 3. Okay, build your parentheses and let's get the original problem back. What would you have to multiply with 3 to get a 12v squared? 4v squared. 3 times 4v squared is 12v squared. What would you have to multiply with 3 to get a -27? A -9. Okay, so now I'm going to cover up my GCF, and since I have 2 terms inside, 1, 2, I want to see if it is this thing that we called a difference of squares. So to be a difference, it has to have a subtraction sign. Okay, we're good there. And then to be a difference of squares, you need perfect squares surrounding the minus sign. And sure enough, they are. If you take the square root of 4, you get a pretty 2. If you take the square root of 9, you get a pretty 3. So those are perfect squares. And if your exponent is even, then it's also a perfect square. So every time it's a difference of squares, it's two sets of parentheses, one has a plus, one has a minus. And then you take the square roots. So the square root of 4v squared is 2v, because 2v times 2v is 4v squared. And the square root of 9 is 3, because 3 times 3 makes 9. And then this GCF we took out at the very beginning, don't forget to drop him. Shoo! And that's our answer. And do you see it? Yep, it's answer choice B. Okay, number 17 says to factor. And it says enter factors with parentheses, no spaces, and factor with smallest constant first. Okay, so we need to practice that concept. All right, so first I always look for a GCF, and there's a 1 right there. So I look to see if anything can divide into 2, 1, and 6. And nothing can go into 1 besides 1. And they don't all have x's. Okay, as soon as I count that there's 3 terms, 1, 2, 3, I do this a times c rooftop. So a times c, 2 times negative 6 makes negative 12. And I want the numbers to add to make the b, which is negative 1. So I'm looking for 2 numbers that multiply to make negative 12 and add to make 1. Okay, I know what they are. I hope some of you already know. I'm going to show you with my calculator again. So you type in what you want them to multiply to be, negative 12, and then divided by x. Then I go to my table, so second graph. Okay, I need to find 2 numbers that add to make negative 1. And I'm already here. These 2 numbers add to make negative 1. These 2 add to make a positive 1. Those 2 add to make positive 4. Those 2 add to make 11. So it's these guys. These add to make negative 1. That's what I want. Negative 4, positive 3. Bing, 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 bing. Negative 4, positive 3. Okay, so now I'm going to Dr. D. Drop, replace, drop. I drop the 2x squared. I replace the negative 1x with these guys. Minus 4, remember is x. Positive 3, remember is x. And then drop the minus 6. So drop, replace with the numbers you found, and drop. Okay, as soon as you spot there's 4 terms, 1, 2, 3, 4, we factor by grouping. So I group together my front 2 terms, and I take their GCF out. So what's the greatest number that can go into 2 and also go into 4? Greatest number that can divide into 2 and divide into 4? 2. They both have x's, and the greatest number they both have is 1, and that's because he doesn't have more than 1. Okay, every time there's a GCF, you build 1 set of parentheses behind it, and you want to get that problem back. So 2x times what makes 2x squared? X. 2x times what makes negative 4x? Negative 2. Okay, now in the back. I am going to cheat. Whatever is in this set of parentheses has to be what's in this set. So I'm just going to copy it over. And now I'm going to backtrack and find the GCF. What's the greatest number that goes into 3 and also goes into 6? 3. And whatever this sign is, drop it. Now let's make sure this distributes to give me this. So 3 times x is 3x, and 3 times negative 2 is negative 6. Yay! Okay, so I'm going to build my 2 sets of parentheses. Whatever I wrote here and here, I write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, I write right here. So that will be 2x plus 3. Okay, so when it tells you to enter it with parentheses, no spaces, so there'll be no spaces anywhere, and with smaller constant first, that's when you'd look to see if negative 2 is a smaller number than positive 3, or which of these is smaller. And since negative 2 is smaller than positive 3, then you would write the x minus 2 first and the 2x plus 3 last. So if I backtracked and I showed you a different one, if I had to write this one with the smallest constant first Is -1 smaller or is -9 smaller? -9 is smaller. So that means I would have to put the 4t minus 9 first and the t minus 1 second. So that's what it means when it says enter it with the smallest constant first. Okay. All right, this one here. So my first rule of factoring is to always look for a GCF. So I've looked every time today since we've been factoring. And is there anything that can go into 2, 10, 2, and 10? 2. All even numbers can be divided by 2. So 2 can go into all of them. Now let's look. Do they all have x's? Nope, it's just a 2. All right, so every time there's a GCF, you build one set of parentheses. And now you need to figure out what's going to go in here. So when you distribute the 2, you get the original problem back. So what would you have to multiply with 2 to get 2x cubed? X cubed. What would you have to multiply with 2 to get a negative 10x squared? A negative 5x squared. What would you have to multiply with 2 to get a negative 2x? A negative x. And what would you have to multiply with 2 to get a 10? A positive 5. Okay, so now we're going to ignore the GCF. I'm going to cover them up with my finger. And I see we have 4 terms. 1, 2, 3, 4. So every time there's 4 terms, we factor by grouping. So I group together my front 2, and I take their GCF out. So there's nothing that can go into 1 and 5 besides 1, but they both have x's. What's the greatest number of x's they both have? They both have 2 x's. So you could put 1x squared or just x squared. Okay, every time there's a GCF, remember, build one set of parentheses. Now let's get these guys back. X squared times what is x cubed? X. X squared times what is a negative 5x squared? Negative 5. Okay, now let's look at the GCF in the back. First, let's cheat them. Whatever you write here, you got to write here. Now backtrack. Is there anything that can go into 1 and 5 besides a 1? Nope. So the GCF's a 1, and then whatever this sign is, drop it. Now let's make sure this distributes to give me this. So negative 1 times x is negative x, and negative 1 times negative 5 is positive 5. Okay, yay, I haven't messed up. So I'm ready for my answer. Whatever I wrote here and here, I write one more time. And then whatever's left over, which is the guy in the front and the guy in the middle, goes here. So that is x squared minus 1. And then this GCF I had at the very beginning, this 2, don't forget to drop him. Shoo. Now, when I look over here, first I'm going to see who took a GCF of a 2 out. And B, C, and D did, so A's out. Now, I notice that none of these answers match mine, and I'm actually really glad that none of these answers match mine, because if one of them did, you'd probably miss it. So there is something else I can do. Somebody in these parentheses is special. Do you know who it is? It's this guy. This guy is a difference of squares. It's got a minus sign, and that's what makes it a difference, and the numbers surrounding it are perfect squares. Your variable has an even exponent, and 1, of course, is a perfect square. So this is when you factor with 2 sets of parentheses, one with the plus, one with the minus, and then you write the square roots down. The square root of x squared is x, because x times x is x squared. And the square root of 1 is 1, because 1 times 1 is 1. And then you just drop your x minus 5, and then you just drop your 2. Now I'm complete. And can you tell which one it is? It is B. So it's written slightly out of order from what I have it in, but it means the same thing. Okay. And then number 19 here actually goes with Unit 3. This is not a part of factoring. So this says to solve the system and enter it as an ordered triple with parentheses and no spaces. Okay, so first it has to be ready for the matrix. Do you think it's ready? No, you need x, y, and z on the left and the constant on the right. So I need to get this negative 2z over here. Okay, so my 3x is where he should be. I'm going to just recopy him. My positive y is where he should be. I'm going to recopy him. But how do you move the negative 2z over to the left side? You add it, so it's a plus 2z. And then the constant is on the right, and that's where he's supposed to be, so just recopy the 1. Okay, let's look at the next equation. The 2x is on the left like it should be, so let's just recopy it. But the y is not on the left, so how do we get the y to the left? We subtract it, so it's a minus y. The z is on the left like he should be, so just recopy him. And the constant is on the right like he should be, so just recopy him. Okay, last equation. The x is on the left like he should be. The y is on the left like he should be. The z is on the left like he should be. And the constant's on the right like he should be. Okay, so I didn't have to do anything to the bottom equation. All right, so I'm going to put this in my matrix. All right, so I go to matrix 3 times total. Here's the first time. Second, x to the negative 1. The first time you're in here, you go to edit. So I right arrow over to edit. It is 3 rows and 1, 2, 3, 4 columns. So it is a 3 by 4. Okay, so in front of the x I have a 3, so 3 enter. In front of the y I have a 1, so 1 enter. In front of the z I have a 2, so 2 enter. And my constant is 1, so 1 enter. Then in front of the x I have a 2, 2 enter. Then I have a negative 1. Then I have a positive 1. And then I have a negative 3. Then I have a 1, a negative 4, a negative 3. And this actually happens to be the same matrix that I typed in here when I made the last video. But the last one was ready to go and this one's not. So this one teaches you how to get the matrix ready if it's not ready. Okay, after numbers are in, quit the screen. So second mode, matrix for time number 2. Second, x to the negative 1. Go to math, go down to letter B, REF. Enter. Go to matrix for time number 3. Second, x to the negative 1. Call up the name A, because that's where we stuck it. Enter, enter. And these are our answers. Negative 1, 2, 1. So negative 1, 2, 1. And I would type it with parentheses and no spaces. So parenthesis, negative 1, comma 2, comma 1, parenthesis. No spaces in between. Okay, and that is to help you with your 2 redemption tests, 1 over Unit 3 and 1 over factoring. I wish you well. I hope you do great. Smiley face.